So now if I take inverse Z transform, I'll get small x of n, which will be equal to 3 by 5 is a constant, it will remain as it is. Z upon Z minus 2 will be nothing but 2 raised to n u of n, because a will be 2 here. Minus 3 by 5 is also as it is. This time a will be 1 by 3, so it will be 1 by 3 raised to n u of n. So that's my inverse Z transform. But let us quickly discuss one very important point that should not go missing. If you remember, Z upon Z minus a was not just the Z transform of a raised to n u of n. It was also Z transform of minus a raised to n u of minus n minus 1. Then the question is why we are not considering this inverse Z transform. We should ideally consider this form also. When you write inverse Z transform as a raised to n u of n, you can see that both the signals become causal. The moment you consider this inverse Z transform, so when we consider a raised to n u of n as inverse Z transform, then it gives us the causal inverse Z transform. Whereas when I consider minus a raised to n u of minus n minus 1, it obviously gives me anti-causal inverse Z transform. So it depends on what type of signal you want, and based on that we should choose the inverse Z transform. So when I take both the inverse Z transform as 2 raised to n u of n and 1 by 3 raised to n u of n, this is possible when I assume both of them to be causal. And with that, I have to quickly consider the ROC also, because if you remember, a raised to n u of n had ROC mod Z greater than mod a, and minus a raised to n u of minus n minus 1 had ROC of mod Z less than mod a. So the conclusion is you can't find inverse Z transform without assuming the ROC. When I take this inverse Z transform, I'm assuming ROC that mod Z is greater than 2 and mod Z is greater than 1 by 3, which in common will be mod Z greater than 2, because something which is greater than 2 and greater than 1 by 3, the common part will be greater than 2. Something which is greater than 2 will also be greater than 1 by 3 automatically. So only when ROC is mod Z greater than 2, this will become my inverse Z transform. That means, are there more inverse Z transform possible for the same Z transform that we have obtained? The answer is yes. So again, taking inverse Z transform, and this time taking ROC as mod Z less than 2 and mod Z less than 1 by 3, which will have a common ROC of mod Z less than 1 by 3, because something which is less than 1 by 3 is also less than 2. Now this time x of n will be, both are less than 1 by 3 means anti-causal signal, it should be of this form. So 3 by 5 is a constant, so I'll have to have a minus sign first. Minus a is 2 here, so 2 raised to n u of minus n minus 1. So this is my first signal. Minus 3 by 5 minus, for the next part a was 1 by 3, so 1 by 3 raised to n u of minus n minus 1. So that's my complete Z transform. Obviously one can write this further as minus 3 by 5 2 raised to n u of minus n minus 1, and this minus minus will make it plus 3 by 5 into 1 by 3 raised to n u of minus n minus 1. Now this was exterior to circle, this was interior to a circle. Can there be third type of inverse Z transform also possible? The answer is yes. Let's see what will be that. So once again I'm saying that taking inverse Z transform, and this time I'm going to consider ROC as mod Z greater than 1 by 3 and mod Z less than 2, and this will have a common ROC of mod Z greater than 1 by 3 less than 2. So this is what exactly same thing I've written here as a common ROC. So what will be x of n in this case? So now you have to be very careful. See, when I say mod Z greater than 1 by 3, I'm assuming this signal to be causal. But when I say mod Z less than 2 interior to a circle, means I'm assuming signal to be anti-causal. So the signal with factor of 2 has to be anti-causal. So that means 3 by 5. Anti-causal inverse Z transform will be minus 2 raised to n u of minus n minus 1. And the second signal, this was minus 3 by 5 already. The second signal is assumed to be causal signal because ROC is exterior to a circle. So this inverse Z transform will be nothing but a raised to n u of n, which is 1 by 3 raised to n u of n, and hence overall this becomes minus 3 by 5 2 raised to n u of minus n minus 1 minus 3 by 5 1 by 3 raised to n u of n. You can see one part is anti-causal, one part is causal, and hence overall this signal becomes both sided signal. Final conclusion is we have got 3 types of inverse Z transform for the given Z transform. This was completely a causal inverse Z transform because you can see both the terms have u of n. This was completely anti-causal inverse Z transform because both the terms have u of minus n minus 1 present. And the third inverse Z transform that we got is both sided. So that's one example on inverse Z transform where we use partial fraction expansion. Let us look at few more examples just to get an idea on how inverse Z transform is carried out. But now let us go to the next part under Z transform, which will be little more important with respect to the subject of digital signal processing.